I'm going to walk through the chapter 4.8 story problems with you that I've assigned, as well as a couple of the other ones. I know it's a really small class today, but we need to make sure that we get through these story problems that you guys understand. The first concept I want to talk about is bearings. Okay, it's not the wheel bearings in your car or anything like that in your washer. We're talking about bearings as to location and directions. If you are on the ocean, it's how do you navigate from one area to another area. It is talking about our cardinal directions, which is north, south, east, and west. So given directions given when using surveying or navigation, it measures the acute angle, acute, on a path or line of sight that makes it with a fixed north-south line known as our axis. Okay, so basically what it is, this is north, this is south. Okay, now you have to be touching the north and the south axes. Okay, so for example, if I say I'm going to go northeast, I'm going to start from the north axis and I'm going to go to the direction of the east, let's say 52 degrees. This is 52 degrees. It's touching the north axis and it's going toward the east. So this would be a bearing of north 52 degrees east. Do we all understand that? Yes or no? Okay. If I was going south, let's say 34 degrees west, I would start on the south axis. You with me? And then I would go toward the west 32 degrees. So this would be 34 degrees in between the angle and the south axis. Yes? Now there is a problem where it wants you to go the opposite direction. So for example, it'll say east 12 degrees north. You know what that means? It means it's going off of your west and east first. And it's going to say, okay, well, here's your east axis. You're going to go up 12 degrees toward the north. So this is 12 degrees right here. Does that make sense? Yes? Do we understand that? There's one problem in your textbook that is actually going in that physical area, okay? That's what it means whenever we're talking about bearings. Any questions over that, yes or no? Okay, excellent. Now, this is actually example number 5 in your textbook. And I'm a big believer in that to look at the picture is great that they give you. And if you are in your textbook, you can actually see the picture. The textbook, the example I'm talking about is on page 322. They give you a lovely little picture. The picture they give you is this right here. Well, that's all great, but I don't understand it. So oftentimes what we need to do is read the problem and draw our own picture, comparing our picture to their pictures. That's what we're going to go ahead and do. Okay, so a ship leaves port at noon and heads due west. Which direction is west? Is that left or right? West is left. So I need to be over here. So this is my ship, and that's going to be at noon. 12. Yes? I can't draw. So this is why everything's a star. Okay, so stick with me on that. Okay, so my ship is right there, and it says I'm leaving at noon. I'm heading due west 20 knots, or 20 nautical miles per an hour. What's a nautical mile? Nautical means water, yes? So we're talking that we're on the water, and we're going miles per hour, kind of like nautical miles per hour in the water. Okay, so I'm going to go west, and then it says at 2 p.m. the ship changes course. So how long am I traveling? 2 hours. So I'm going to have, here's my first hour, here's my second hour. Would you all agree? Each one of those, I have traveled 20 nautical miles. 20 nautical miles per hour, yes? Do we all understand that? So how many total miles have I gone, nautical miles? 40. That would make sense, right? So together I've traveled 40 nautical miles. Now, here's the thing. At this point, I'm going to go ahead and I'm going to put a red axis there. Why am I putting a red axis there? Because it says that I am now, the ship is changing the course and going north 54 degrees west. So that's a bearing, is it not? That bearing is what I need to talk about here. So here's my bearing, but I need to go, here's my north, but I need to go west, don't I? So if I'm going west, 54 degrees west, this angle right here is 54 degrees. Do we all see that, yes or no? That's what it means to have a north 54 west bearing. Make sense? Okay. And it says, as shown below in the figure, find the ship's bearing distance from the port of departure at 3 p.m. So I stopped moving after 3 total hours. So I left the port at noon, traveled west for 2 hours, changed the direction, and then for another, how many hours? 1 hour. So this is only 1 hour. This is where my ship is at 3 p.m. Do we understand that? So what is this distance right here? 20. And it says to find the ship's bearing and distance. What does that mean? To find the ship's bearing and distance. I need to know the distance from 12 to noon. Or from noon to 3. Do you see that? I need to know this. This is C, which is called my hypotenuse, right? But that's of an oblique triangle. Would you agree? Well, have we been learning about oblique triangles? No. What have we been learning about? All of our triangles have been what? Right triangles. Can I make this into a right triangle? I could find the altitude and drop it down and make it into a right triangle. Now, I also need to know the bearing. Whenever I say the bearing, I want this angle right here. So I want C, and I want this bearing of theta. Do we all understand that, yes or no? That's what it's asking for. So how do I go about doing that? Well, the way I go about doing that is I'm going to simply drop down the altitude, and I'm going to make this into a right triangle. Can we see that? This is called h, which is the height of the triangle, which is called the altitude. Do we all get that, yes or no? Okay, what I don't know is the distance from my right angle over to where I change directions. So since I don't know it, what should I label it to be? X or D, it's a distance. I'm going to label it D. Yes? Now, do you see that I have 3 triangles here? I have this small triangle that has H and D. Do we see that? I have the oblique triangle. Do we see that? And then I have the larger triangle that is also right. Do you see that there are 3 triangles? We need them all. Do we all understand that? The oblique is the actual story problems triangle. Would you agree? The bigger triangle is what we made, and the smaller triangle is what we're going to solve to first be able to solve the bigger one. So we're going to focus on the smaller triangle first. So if we're focusing on the smaller triangle, I need to find the angle right inside here. How do I find that angle? Why is that angle 90 minus 54? Because this is a right angle right through here, right? That's a right angle, right? So I'm going to go ahead and I'm going to say, okay, 90 minus 54. What is 90 minus 54? It is 36. So guess what? This is 36 degrees in there. Can I find H and D now? Can I find H and D now? I sure can. So how do I find H? Well, H is, according to this angle 36, what is H? What is D? So if this is H is opposite and D is adjacent, what trig function deals with opposite and adjacent? Tangent. So the tangent of 36 is equal to my H over my D. Is that very helpful? Why is that not helpful? Because there's 2 unknowns. What I did not use was the 20. So instead of using tangent, what should I be using? I need to find the 20. What is the 20 according to the 36? So what trig function deals with this one and with the 20? So the sine of 36 is equal to h over 20. So my height is 20 times the sine of 36. That is equal to my height. Would you agree? So I'm going to save us some number punching here, and I'm going to give you what that is. That tells you that your height is going to be 11.76 is your height. So I found h. So how do I find d? Well, now I'm going to do this one in 20. What is that? Okay. Cosine. So the cosine of 36 is equal to d over 20. So 20 times the cosine of 36 is equal to d. So this time, that is going to give me 16.18, I believe. Okay, so this is going to be 11.76. This is going to be 16.18. So what is the total length of this long triangle now? The parts added together equal the whole. So this part is 16.18 and this part is 40. So what's that totally give me? Very good. Okay, so now if I start focusing on the big triangle, can I find C now? Easy. How do I find C? Here's the one length. Here's the other length. How do I find C? Pythagorean theorem sounds great to me. So a squared plus b squared is equal to c squared. So this is going to be 11.76 squared plus 56.18 squared. And I'm going to take the square root of that, and it's going to give me c. If you type that in your calculator, I don't know if I have that. Square root of 11.76 squared plus 56.18 squared is going to give you 57.40. So this is 57.40 nautical miles. Is that part of my answer? It absolutely is. Do we understand that? So with that being said, what's the next thing I need to do? The bearing. Okay. So how the heck do I find the bearing? What do you mean find the inside one first? What does that mean? Oh, so I still did make my big triangle then, yes? Good. So if we go ahead and have that highlighted there then, I'm going to move this 20 down so that you know that's not the angle. I'm looking for this angle right here. How do I find that angle? Well, that angle, I have a side here and a side here, and I know that side. So what trig function would you like to utilize? Any of them. Pick one. Sine. So the sine of theta is going to be equal to the opposite, which is 11.76 divided by 57.40. How do I find theta? How do I get rid of that sign? How do I find theta? Arcsine, very good. So theta is equal to the sine inverse of 11.76 over 57.40. So if I type that in my calculator, what I'm going to get, 11.6 divided by 57.4, that gives you 11.82. degrees. So that means that degree right there is 11.82. That's what that angle is. So how do I find the other part of it? I just need to do 90 minus. So the bearing is going to be found by taking 90 minus 11.82. 78.18 degrees. Now, tell me, what's the actual bearing? How would you write that? Give me the directions. Because this is where we're at. And this is what I'm looking for. So how would I describe that? Very good. North, 78.18 degrees west. Does that make sense? How many of you read the example, but did not understand what all they were doing until I just now did this? Does that make sense to you now? Make more sense? Excellent. Okay. Be prepared to be able to do this problem on the test. There's a lot of understanding in that problem, a lot of trig and understanding where those triangles are at. Okay. All right, now let's go ahead and do, this was a homework problem. A ladder 20 feet long leans against the side of the house. I can't draw, but it doesn't matter that I can't draw. Here's my house, and here's my ladder leaning. It's leaning against the house, so here's my triangle, right? How long is my ladder? I mean, it looks like a really small house. It's 20 feet, but that's okay. So this is 20, and what is my angle at which this thing is leaning up against the house? With the ground? 80 degrees. Right, the degrees symbol, all right. 80 degrees. What is it asking to find? The height. Where's the height? It's against the house, so I need this. So what trig function would you utilize? Here's your 90 degrees. What trig function would you utilize? Opposite over hypotenuse, which is what trig function? So the sine of 80 degrees is equal to opposite, which is going to be x, over hypotenuse, which is going to be 20. Do you know how to solve it from there? Multiply by 20, and you're going to make sure that you are in degree mode. Okay, let's go to number 21. The sonar of a Navy cruiser detects a submarine that is 4,000 feet from the cruiser. Okay, here's my cruiser, and here's my water. Yes, it is on the water. I know you love my drawings, don't you? Okay, the submarine is down here. It's in the water. Yes, and it says that it's 4,000 feet away. Bam. That line represents 4,000 feet, right? And it says the angle between the water level, can you see the water level, and the lovely little submarine is 31.5. So 31.5 is going to go right in there, correct? How deep is the submarine? What is it wanting? What's the depth of this thing, right? So what trig function are we talking about right now? Opposite over hypotenuse. Very good. So we have the sine of 31.5 is equal to x over 4,000. Do you know how to solve it from there? Yes, you do. Do we understand that problem? How many of you got that yourselves? Excellent job. Okay, next one. How long will it take for the plane in problem 27 to climb an altitude of 10,000 feet? Okay, think about this a moment. How many of you have been on a plane before? You're on the fairway, you're on the runway, yes? And you are sitting there, and next thing you know, you just start taking off. Yes? You have the runway here, correct? And then you start to go slowly into the air. Would you agree? The angle at which you are slowly going into the air is at what degree? Well, if we read number 27, it says that the angle of climb is 18 degrees. Inside is the 18 degrees. The plane speed is 275 miles per second. Or I should say 270, what does it say exactly? Make sure we got it. Its speed is 275 feet per second. Okay, making sure that I had that correct. Now, it wants to know when the altitude is 10,000 feet. Where does 10,000 go on my problem? All right, 10,000 goes right there. I need to know this distance. You know why I need to know that distance? Because distance is equal to rate times time. And at that point, I then can use the 275. Do we all understand that? So I need to know this distance, which we're going to label to be x. What trig function deals with that? Sine. So I have the sine of 18 degrees is equal to my opposite 10,000 over my hypotenuse x, correct? So at this point, I'm going to have x is equal to 10,000. I'm going to go ahead and divide by the sine of 18. Yes? And whenever you plug that in, what you are going to get is that x is equal to 32,360.68. That is what x is going to be. That is the distance. But the question is, how long? It wants time. It doesn't want distance, does it? So guess what we know? We know that distance is equal to rate times time. The distance that I traveled is 32,360.68 feet. I know that my rate of the plane that it's traveling at is 275 feet per second. I don't know the time that it's taking me to travel that distance. So how do I find the time? Divide by 275. And whenever you do that, we're going to get 117.67 is your time. And this is seconds per foot. You know what that means? I have reached an altitude of 10,000 feet in the air within 117 seconds, which means a little bit over a minute and a half, I've reached an altitude of 10,000 feet. Does that make sense? Part B, this is just part A. Part B is now replacing that 10,000 with 16,000. So can you tell me about what number you are going to have for time? Let's round that to 20,000. 20,000 would be twice the amount, right? So what's twice the amount of 117? 234. So my answer has to be smaller than 234 seconds. Do we understand that? Makes sense. Okay, excellent. Next one that we're going to talk about is number 32. Number 32 is the last story problem that I made you guys do by yourselves. It says an airplane flying at 600 miles per hour has a bearing of 52 degrees. 52 degrees from which axis? We don't know. Let's keep reading. After flying 1.5 hours, how far north and how far east has the plane traveled from its point of departure? Okay, well, make things real easy on yourself. I know I'm going north and I'm going east. I need north and I need east. Do we see that? There's my triangle. Would you agree? Yes? But what we haven't used is this concept right here. What do those mean to you? What's the 600? It's the rate at which we're traveling. What's 1.5 represent? How long we're traveling. You know what that means to me? Distance equals rate times time, right? So the distance that I have to find, my rate is 600. My time that I'm traveling that rate is an hour and a half. So how far did I travel? (900 miles is what I traveled. Where's the 900 go, according to my story problem, if my right angle is right here? Where's 900 go? This is where I started. This is where I ended. It's the hypotenuse, guys. Right? Okay. That's what else is telling me. My bearing was 52. So that means right here is 52. Do we understand that? Yes? So how do I get the inside of my angle? I'm going to take 90 minus 52. And what does that give me? 38. That gives me my inside angle. Can I now find north and now find east? Yes. How do I go about that? Well, my north is going to be what compared to 38? And what's 900? So what trig function is that? So the sine of 38 is equal to the north divided by the 900. So the north is equal to 900 times the sine of 38. Correct? And you can calculate that. Okay, so what about the east? How do I find the east? What's east compared to 38? So what trig function deals with adjacent? Cosine. So I'm going to have the cosine of 38 is equal to the east divided by 900. So the east is equal to 900 times the cosine of 38. Do we understand that, yes or no? Now you have to get the physical numbers. I'm not going to do the calculation for you. You have to finish that and check it. Okay, so it's not quite all the way done. Okay, I want to spend my last few moments talking about this problem right here. This is not a homework problem, but I want to make myself very clear. Just because I did not assign all of those story problems doesn't mean you're not held responsible for them. Yes? So if we look at problem 34, it says two fire towers are 38 kilometers apart from where Tower A is due west of Tower B. Okay, here's Tower A, and it is clearly west of Tower B. It's to the west of it. A fire is spotted from the towers, and the bearings from A and B. Do you see this word down here? Respectively. Does anybody know what respectively means? The first measurement goes with the first letter. The second measurement goes with the second letter. The third measurement goes with the third letter. The fourth measurement goes with the fourth letter. You with me? So this one says east 14 degrees north. So this east 14 degrees north goes with A. So that means I'm starting from my east axis and I'm going toward the north axis 14 degrees, which is why it's on the inside of the triangle. Do we understand that? Then I'm going to go west, so I'm at Tower B now, and I'm going to be on the west axis going up toward the north 34 degrees. So that's why it's on the inside of the triangle again. Do we understand that, yes or no? Excellent. This is to find the distance. Now, folks, I want to make myself very clear. D is in the middle. And it's kind of hard to see this. So I'm going to draw this triangle. And it is not quite an isosceles triangle. It's not. You can clearly see that. And maybe I should even draw that even a little bit more. Is that better? Yes. Okay. So here's A. Here's B. Inside here is 14. Inside here is 34. What it wants you to find is D. Would you agree? Now, what does both of them share? D, correct? The reflexive property says that D equals D. I equal myself no matter what, no matter in whatever scenario. So what you can do is you can find D in triangle 1, and I'm going to label this as triangle 1, and I'm going to label this as triangle 2, so that you can then do a calculation yourself to figure out exactly what you want. Now, what we did not use was the fact that they are 30 kilometers apart. Would you agree? I want to separate the 30 kilometers. So if I look in the first one here, this is going to be X units from here to here. Would you agree? The whole distance from A to B is 30. So what does this leave this part to be over here? If the whole thing is 30 and part of it is x, what remains to be the other part? If the whole distance is 30, this part is x, so that means 30 minus x is what remains. Why? Because the whole distance is 30. Do we all understand that? Yes? And it's very important that you listen to what my words I'm saying. The whole distance means the parts added together equal the whole. If part is undefined and that's x, I don't know it, it's undetermined. The remaining part of it is the whole part taken away from, is the whole distance and take away the part, which is why it's 30 minus x. Okay, so what we're going to do is we're going to find d in triangle 1. So triangle 1, we need to find d. How do I find d in triangle 1? How do I find d in triangle 1? What is d according to 14 degrees? What is it? Opposite. What is x? What trig function deals with that? Tangent. So the tangent of 14 degrees is equal to d divided by x. Yes, there are two unknowns, but my goal here is to find d. So how do I solve for d? Multiply by x. So x times the tangent of 14 is equal to d. Box that in. Triangle 2. Still finding d. So what is d according to the angle 34 degrees? What is 30 minus x according to 34 degrees? So what trig function deals with that? So the tangent of 34 degrees is equal to my opposite, which is d, divided by my adjacent, which is 30 minus x. I'm solving for which letter? D, because we want to use the reflexive property. So the tangent of 34 times 30 minus x is equal to d. Box that in. So now that I have d is equal to d, what can I do? D equals d, which means I can set those two expressions what? Equal to each other. So that means I have x times the tangent of 14 is equal to the tangent of 34 times 30 minus x. Yes? Now, the beautiful thing about this is the tangent of 14 is just a number. Would you agree? It's just a number. So if you're just plugging numbers, and if you want to go out 3 decimal places as much as you can, I did not because I just didn't. This is going to be 0.25 times 30 minus x. Can I solve that for x now? Right? The tangent of 14 is 0.67. The tangent of 34 is 0.25. If I distribute, what you're going to have is 7.5 minus 0.25x. Bring that x over, and you're going to have 0.92x is equal to 7.5. So x is equal to 8.15. That's what x is. But that's not what d is. What's d? Well, how do I find d? What's d defined to be? D is x times the tangent of 14. So if d is going to be x, which is 8.14 times the tangent of 14, I now can say that d is equal to 5.76 kilometers away. That is the distance. Sorry. Yes? Does that make sense? Okay. Make sure that you look at problem 36 tonight for homework. Okay? Tomorrow we will review, and you'll be looking at a test probably on Monday. Have a great day, guys.